Hi y'all! So we started with Newton's third law, then we jumped to Newton's first law. Now it's time for Newton's second law. I saved the best for last because I get to knock things over. So for those of you who said I was talking too fast on the last one and you couldn't take notes fast enough, Newton's second law, the mathematical one. Newton's second law states that the force an object has to do with how much mass it has and how fast it's going, its acceleration. So let's take a look at our force cars, shall we? So this force car right here, if I put it on my handy-dandy little scale here, it is just over 100 grams. So let's see how much force our car has. Here we go, you ready? I'm gonna see, just by letting it go, how hard it's gonna hit our target. That was kind of anticlimactic, right? Didn't really do that much. So let's go ahead and rebuild our wall. Well, there's two things that we can do to increase the force that it's going to hit our wall with. Well, what are they? We can increase the mass or we can increase the acceleration. It's easiest to increase the acceleration. How do you think we can increase acceleration? I can push it. Any other ideas? Let's increase the height of our plane. What do you think? Well, it seems kind of obvious, right? We're going to go ahead and let this go again from the same spot with the back wheels about 2 centimeters away from the back wall. And we're going to let it go. Here we go. Oh, much more significant. Much more significant. Because what we did is we increased the acceleration. When it went faster, the mass was still the same, but when it went faster, the overall force was increased and it had more strength to knock down our target. Let's go ahead and rebuild our target. So we increased the we increased the acceleration. So what's left? We have to increase the mass. Well, remember when we talked about independent variables and dependent variables and controls? And remember we want to keep everything as perfectly the same that we could other than what we're testing? I could get, I don't know, like my car up in here and it'll probably have more force because it'll have more mass, right? But we want to control as many variables as we can. So the same ramp, the same target, the same force car. Whoops, this one. All right, the same force car. So now we're going to go ahead and bring our target back down, our ramp back down to what we first started with. All right, are you ready? How we're going to increase our force car is we're going to add weight to it. Here on Earth, we can measure weight, right? But in this case, we're going to go ahead and measure our mass, our total mass. And our total mass here is just almost 800 grams. So here we go. We need to remember to put a seatbelt on. We don't want what happened to him. What happened to Bob? Sorry, Bob. Oh, anyway, sorry. It's okay, it's okay, it's okay, I'm okay. All right. Okay. So I have this box of screws right here. We're gonna go ahead, we increased our mass, but we're gonna put a seatbelt on him just to make sure he stays nice and safe. We don't want what happened to him. We don't want what happened to Bob to happen to him. All right, so here we go. So now let's see what kind of impact it's gonna have. Remember, when we did it without any additional weight, it barely made it to the target. Let's see what happens this time. We definitely increase the force. So what are two ways we can increase force? We can increase the acceleration, or we can increase the mass. Remember, this is what we were talking about when we very first started talking about Newton's laws. Would you rather get hit by a bowling ball or an itty bitty teeny tiny piece of metal? Well, the force they have depends on how fast they're going. So thank you very much for joining us for Newton's second law, and I look forward to reading all about your amazing scientific writing that you're going to be submitting today. So talk to you later. Bye.